15 amp Plugmold strip on a 20 amp small appliance circuit may present issues related to overcurrent protection and code compliance. Connecting a 15 amp Plugmold strip to a 20 amp circuit could create an electrical hazard if the total load on the Plugmold exceeds 15 amps. Electrical codes generally require circuits to be rated for the maximum load they will carry. A kitchen small appliance circuit rated for 20 amps would be incompatible with a 15 amp Plugmold strip, as the Plugmold is undersized for the circuit. Several alternative solutions exist. Firstly, install a dedicated 15 amp circuit. This involves running a new circuit from the electrical panel to the counter area specifically for the countertop outlets. Secondly, use a 20 amp Plugmold strip. Replace the 15 amp Plugmold strip with a 20 amp version that is compatible with the existing 20 amp circuit. Thirdly, install a junction box directly under the cabinet and connect the two separate circuits to it, allowing both the small appliance circuit and the separate circuit for the countertop outlets to be used. Fourthly, consider using under-cabinet lighting to provide illumination instead of countertop outlets, eliminating the need for outlets under the cabinets altogether. When considering any electrical work, perform load calculations to determine the total load that will be placed on the circuits. This includes accounting for appliances, lighting, and other devices that will be plugged in. Electrical safety is paramount, so always consult with a licensed electrician to ensure that any modifications or installations comply with code requirements and provide a safe electrical environment. The 2017 National Electrical Code, or NEC, may provide additional guidance. When dealing with electrical circuits, it is important to understand the ratings of the components involved. A 15 amp Plugmold strip is designed to handle a maximum current of 15 amps. Connecting it to a 20 amp circuit means that the circuit breaker protecting that circuit will not trip until the current exceeds 20 amps. This could potentially overload the Plugmold strip, leading to overheating, damage, or even a fire hazard. To ensure electrical safety, it is crucial to match the ratings of the components to the circuit's capacity. The use of a 15 amp Plugmold strip on a 20 amp circuit violates electrical codes. The code mandates that all components in an electrical system must be rated for the maximum current they are expected to carry. Using an undersized component like the 15 amp Plugmold strip creates a potential safety hazard. There are several ways to address this issue and bring the electrical installation into compliance with the code. Installing a dedicated 15 amp circuit involves running a new circuit from the electrical panel to the location where the countertop outlets are needed. This circuit would be protected by a 15 amp circuit breaker, ensuring that the Plugmold strip is adequately protected from overcurrents. While this solution may require more extensive electrical work, it provides the safest and most reliable way to comply with code requirements. Replacing the 15 amp Plugmold strip with a 20 amp version is another option. This ensures that the Plugmold strip is rated for the full capacity of the 20 amp circuit. However, it is essential to verify that the Plugmold strip is specifically designed for countertop use and meets all relevant safety standards. Installing a junction box under the cabinet allows for the connection of two separate circuits. One circuit can be the existing 20 amp small appliance circuit, while the other circuit can be a dedicated 15 amp circuit for the countertop outlets. This approach provides a flexible and code-compliant solution, allowing for both general appliance use and specific countertop needs. Using under-cabinet lighting as an alternative to countertop outlets is another way to address the issue. Under-cabinet lighting provides illumination without the need for additional outlets, eliminating the code violation. This solution is particularly effective if the primary concern is to provide adequate lighting for the countertop area. When planning any electrical work, it is essential to calculate the total load that will be placed in the circuits. This involves adding up the power consumption of all appliances, lighting, and other devices that will be connected to the circuit. The total load should not exceed the circuit's capacity, ensuring that the circuit breaker will trip in the event of an overcurrent. Consult with a licensed electrician to ensure that all load calculations are accurate and that the electrical system is properly designed. Electrical safety is of utmost importance. Always consult with a licensed electrician to ensure that any modifications or installations comply with code requirements and provide a safe electrical environment. A qualified electrician can assess the specific situation, identify potential hazards, and recommend the most appropriate solutions. This ensures that the electrical system is installed safely and meets all applicable codes. The NEC provides detailed guidelines for electrical installations. It is essential to consult the NEC to ensure that all electrical work is performed in accordance with its requirements. The NEC covers various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. Adhering to the NEC ensures that the electrical system is safe and reliable. In the scenario described, the rejection was likely due to a combination of factors, including overcurrent protection concerns and code violations. The 15-amp Plugmold strip was deemed incompatible with the 20-amp circuit because it could pose an electrical hazard if the total load on the Plugmold exceeded 15 amps. This situation violates electrical codes, which require circuits to be rated for the maximum load they will carry. A kitchen small appliance circuit rated for 20 amps cannot be safely used with a 15-amp Plugmold strip. Addressing this issue requires careful consideration of the available options. Installing a dedicated 15-amp circuit, using a 20-amp Plugmold strip, installing a junction box, or using under-cabinet lighting are all potential solutions. The best approach depends on the specific circumstances and the desired outcome. Regardless of the chosen solution, it is essential to prioritize electrical safety and code compliance. Consulting with a licensed electrician is crucial to ensure that all work is performed safely and in accordance with applicable codes. Additionally, proper load calculations are necessary to ensure that the electrical system is adequately sized for the expected load. The rejection serves as a reminder of the importance of adhering to electrical codes and prioritizing safety. Electrical installations must be carefully planned and executed to minimize the risk of electrical hazards. A qualified electrician can provide valuable guidance and ensure that all work is performed safely and in compliance with codes. When dealing with electrical circuits, it is important to understand the relationship between voltage, current, and resistance. Voltage, measured in volts, is the electrical potential difference that drives the flow of current. Current, measured in amps, is the rate of flow of electrical charge. Resistance, measured in ohms, is the opposition to the flow of current. These three quantities are related by Ohm's law, which states that voltage equals current times resistance. Understanding Ohm's law is essential for analyzing electrical circuits and ensuring that they are operating safely. Another important concept in electrical circuits is power, measured in watts. Power is the rate at which electrical energy is transferred or consumed. It is calculated by multiplying voltage by current. The power rating of an appliance or device indicates the amount of electrical energy it consumes per unit of time. When planning electrical installations, it is important to consider the power ratings of all appliances and devices that will be connected to the circuit. The total power consumption should not exceed the circuit's capacity. In the case of the 15-amp Plugmold strip, it is designed to handle a maximum power of 1800 watts, assuming a voltage of 120 volts. Connecting appliances or devices with a combined power consumption exceeding 1800 watts to the Plugmold strip could overload it, leading to overheating, damage, or even a fire hazard. To prevent overloading, it is essential to carefully calculate the total power consumption of all devices connected to the Plugmold strip. If the total power consumption exceeds 1800 watts, it is necessary to either reduce the number of devices connected to the Plugmold strip or use a higher rated Plugmold strip. In addition to power calculations, it is also important to consider the ampacity of the wiring used in the electrical circuit. Ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a wire depends on its size, material, and insulation type. The NEC provides tables that specify the ampacity of different types of wires. When installing electrical wiring, it is essential to use wires with an ampacity that is sufficient for the expected current. Using undersized wires can lead to overheating and potentially cause a fire. In the case of the 20 amp kitchen small appliance circuit, it is typically wired with number 12 American wire gauge or AUG copper wire, which has an ampacity of 20 amps. This ensures that the wiring can safely handle the maximum current the circuit is designed to carry. When connecting the 15 amp Plugmold strip to the 20 amp circuit, it is important to ensure that the wiring connecting the Plugmold strip to the circuit is also rated for at least 15 amps. This prevents the wiring from overheating and potentially causing a fire. In addition to wiring ampacity, it is also important to consider the type of overcurrent protection used in the electrical circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. When the current in the circuit exceeds the rating of the overcurrent protection device, it will trip, interrupting the flow of current and preventing damage to the circuit. The NEC specifies the type and size of overcurrent protection devices that must be used in different types of electrical circuits. In the case of the 20 amp kitchen small appliance circuit, it is typically protected by a 20 amp circuit breaker. This circuit breaker will trip when the current in the circuit exceeds 20 amps, protecting the circuit from overloads and short circuits. When connecting the 15 amp Plugmold strip to the 20 amp circuit, it is important to ensure that the Plugmold strip is also protected by an overcurrent protection device rated for 15 amps or less. This can be accomplished by using a fuse or circuit breaker that is specifically designed to protect the Plugmold strip. The overcurrent protection device will trip when the current in the Plugmold strip exceeds its rating, preventing damage to the Plugmold strip and potentially preventing a fire. In summary, connecting a 15 amp Plugmold strip to a 20 amp kitchen small appliance circuit presents several potential electrical hazards. These hazards include overcurrent protection concerns, code violations, and the potential for overloading the Plugmold strip. To address these issues, it is essential to consider the following factors. Firstly, install a dedicated 15 amp circuit to provide adequate overcurrent protection for the Plugmold strip. Secondly, use a 20 amp Plugmold strip that is rated for the full capacity of the circuit. Thirdly, install a junction box to separate the 20 amp small appliance circuit from the 15 amp countertop outlet circuit. Fourthly, consider using under-cabinet lighting as an alternative to countertop outlets. When planning any electrical work, it is important to perform load calculations to ensure that the circuit is not overloaded. Electrical safety is paramount, and it is essential to consult with a licensed electrician to ensure that all work is performed safely and in compliance with applicable codes. The NEC provides detailed guidelines for electrical installations, and it is essential to consult the NEC to ensure that all electrical work is performed in accordance with its requirements. By following these guidelines, it is possible to create a safe and reliable electrical system that meets all applicable codes and regulations.